Alright, hi guys. Today we're going to be looking at surface area and volume of pyramids and cones. And these are a little more difficult than prisms and cylinders, and you will see why. This is the first page of your worksheet today, so if you want to print it out and follow along, I'm going to work through a few examples on the front page, and we're going to fill in some important formulas right here. But before going on to that, let me zoom out and show you a few things. If I was in class, I'd be able to show you this a little better, but what I have here is a pyramid and a prism that have the same base. Okay, so the area of the base is the same, and they have the same height. So what you could show, and you can look this up on a YouTube video, is I could fill this guy up with water and ask the class, okay, how many times do you think it takes to fill up the prism with the water from the pyramid? And so meaning, how many more times bigger is this volume of the prism compared to the pyramid? And a lot of students guess, you know, twice, 3 times, 4 times, and it is actually a third. So if I found the volume of this guy with the same base and the same height, all I do is divide it by 3 to get the volume of the pyramid. So that's where our formula for the pyramid is going to be derived. It's still the area of the base times the height, like it is for a prism, but all we do is divide by 3. Okay, and we'll write that down on our note sheet in just a second. And the same demonstration can be shown for the relationship between the cylinder and the cone. If I have the same height that these guys do, and the same base, it just so happens that the volume of the cylinder is 3 times as big as the cone. So the volume of the cylinder, remember, was pi r squared times h. The cone is just pi r squared h divided by 3. Okay, so again, you don't need to know those. We'll give you those formulas, but it is interesting of, you know, I think why those are true, and it's kind of neat to see that demonstrated in class, okay? The formulas for the surface areas are a little bit more in-depth, so we'll do a little bit of drawing on these pictures here and show you where those formulas come from. Okay. So first of all, pyramids. Okay. So pyramids and cones are difficult because they have 2 different heights. Okay. They're going to have what's called the height that goes straight from the top down to the center, so it's perpendicular. This is the actual height of the pyramid, and that's always used for volume. Okay. Now, this height right here, that's the height of one of the triangles, is called our slant height. Okay. Now, the slant height in some books is denoted with a cursive L, or some use a cursive S. Okay, usually it's an L for slant height. Okay, so it's really hard to visualize this, so I'm going to show you before I kind of continue with this picture. Let me zoom out here. And I've got this net for this square pyramid. Basically, if you were to unfold this, you'd have a square and 4 triangles, which I've created right here. Should have made a little smaller, but we can get the idea. So we've got our square, and if I fold up these triangles, I've created a square pyramid. Okay. Now, if you notice, the net is useful for the surface area. So when I unfold this, notice to find the area of this triangle, I need my slant height. I need the height of the triangle. Okay. And that's this slant height right here, this green. Slant height times this divided by 2 would give you that triangle, and I've got 4 triangles there in this net. So that's what you need to try to visualize. Okay. Now there are different types of pyramids. We can have any type of base, but we want to give you the easy ones. We're just going to have a square base most of the time. They do get a little tricky when that base changes. Okay. So again, that's what we're visualizing, is this slant height right here is the height used for the surface area, because it's the height of the surface, that triangle on the surface. Okay. All right, so let me zoom back in. Now we've hopefully got a little visual with that. And again, you can visualize this kind of here, you guys. The slant height is just kind of like the slope on the way down. This is the height of one of the sides. Whereas the height goes straight down to this middle piece. It like connects my fingers. That's the height. Okay, knowing that, you can see if I connect this piece right here, I can create a right triangle, which I'm going to redraw out here. This is where these get tricky, because we'll only give you one of them. We'll either give you the height or we'll give you the slant height. And you have to be able to use this distance, which is, in a square pyramid, it's going to be half of this length. So if I knew this was 10, this would be 5. So if you know that side and you know, say, the height, you can solve for the slant height or going backwards. Okay. Right. So knowing that, let's write down our formulas now. Volume, like I told you with the demonstration of the water, is going to be the area of the base. Remember, that's what big B stands for. So in this case, it's a square. We would find the area of the square times the height divided by 3. Okay? You always use the actual height of the pyramid for volume. Okay? Now, surface area, I should have left a little more room, but I'll draw the net out here. The net, like I just showed you, is made up of a square and 4 triangles. So essentially, you're just taking the base and you're adding up however many triangles you have. So it doesn't really have a formula, just kind of logically looking at all the faces, just like our prisms. So we're going to take the base plus the triangles. Okay. Not really a formula, just understanding what the net looks like. Okay. Now the cone has the similar relationship. It's going to have 2 different heights. Okay. It has its actual height straight down to the center. And again, that's always used for volume. Whereas the slant height, is going to be used for the surface area. Okay. And you can see if I connect this one with a cone, we can see this is the radius. Okay. So we'll give you one of either the slant height or the height, and usually you have to solve for the other one. So knowing this relationship, height, slant height, radius. You can use Pythagorean theorem to solve for the missing part. Okay. All right, so the formulas on these you'll be given. Volume is, again, we showed you with the water, is going to be the area of the base, which, because it's a circle, is pi r squared times the height, and it's divided by 3. Okay. And the surface area, I could go through a long in-depth description of why it is, but we're going to keep it short, is surface area is going to be your base plus your lateral area. And I'm writing this out so you know which part is what. So the bottom is pi r squared. And the lateral area, so basically everything except the circle, so kind of like this portion right here, can be found by taking pi times the radius times the slant height. Not the height, slant height. Okay, so that's the surface area formula. Like I said, those will be given to you. Okay. I have this written nicer the first time I did it. So I'll leave this up here if you didn't miss anything. And I can only do a 10-minute video, so I'm going to do a part 2 with the 2 examples down below, but those are our formulas. Make sure you have those written down correctly. And you can start part 2 to see how we apply these with surface area and volume.